Okay, guys. I think we're ready. All right, first, show of hands, who's tired? Who got in just a couple of days ago? Yesterday? Who got in yesterday? Who's been here for longer than yesterday? Okay, good. So you guys are awake. You guys can help other people. All right. So, all right, second question. Who in the room uses Linux, or who has used Linux before? Okay, so this might be a disappointment to you all. Who has used Linux never? Oh gosh, this is great. Okay, so this is maybe the first time that this has ever happened when I've given a talk like this, where most of the people in the room are familiar with what we're going to be talking about. So this first section is going to be really easy for you, and this will mostly just be me complaining then and talking about my life, which is okay. All right, so why we use Linux. So the really far back is that there used to be in the United States this place called Bell Labs, which was the research wing of the telephone company. And the telephone company made lots of money, and they spent a lot of money on research, and they did lots of cool stuff. They observed with radio telescopes that they built to do things, testing out horn designs, mostly for microwave communications and other stuff like that. But they had a couple of guys, Ken Thompson and Dennis Ritchie, who worked there, and they wanted to make an operating system for some mini computers that they had. And it's a mini computer, which meant that it fit like kind of in a room instead of multiple rooms, right? So sort of smaller. And so these guys wanted to make an operating system, and they wrote the C programming language, and they used the C programming language to write early versions of Unix. And when we talk about sort of where we're at now with Linux, or the thing that most of us use is Linux, we think about these things as family trees, right? And so there was a beginning, and it started all the way back here, Research Unix, down here. So this is when they first wrote the operating system. And that splits off, and you get these different families. And the family at the bottom, this is commercial Unix, which AT&T, eventually the phone company, they used that for switching and all sorts of other kind of really technical things for how to get your phone call from you to your friend across the country. And that split off into a bunch of other things. So I'm going to ask a couple more questions just because I'm curious. Has anyone here used Solaris before? A Sun operating system. Okay. All right, so the numbers are going down. So this is, these used to be the coolest, and you'll see one in a little bit in my talk. These were like nice machines. Has anyone used IRIX before? Yes, one person. So when I was in college in the late 90s, early 2000s, if you were doing graphics, there were SGI workstations that were like the most powerful graphics workstations. They were really fancy, and they ran IRIX. So every kind of commercial company that sold hardware made their own version of this, and they were all different, all slightly different, but in the same family. They all kind of work in a similar way, right? There's HPUX, which was a HP, IBM had AIX, and then there's all these other kind of like, okay, who's ever used anything in the BSD family, like a FreeBSD or OpenBSD? Okay, a few more people. These are popular because the BSDs you could rewrite to run on nearly anything. The joke was that you could run FreeBSD or NetBSD on a toaster. And they were supposed to be really secure because they were easy to read the code and very small, but not very popular. They kind of like didn't really take off as a user operating system. All right, so there's more family trees. This is sort of, I won't go through all this, but just you can see like where it starts, and then these different lines. Here's Solaris, and here's AIX, and you sort of see where different things connect to different things and things. All this is really just to say these things are all related. So if you understand how to use one of these systems, at least some of the basic things that you know will always work on all of them. Not everything, but some things. Some of the basic commands and other things like that will work on them. Okay. So this over here, which you can't read, it's very small, is the Linux tree. The Linux tree opens up into this. And it's actually a link to, I think it's a Wikipedia page that shows all the different versions of Linux and how they relate to each other. And it's enormous. The reason that it's enormous is because Linux is written and maintained by computer scientists and computer engineers. And if you've ever met an engineer, there's a thing called not invented here that engineers really believe in, and they'll say, this isn't perfect. This thing isn't exactly the way I want. And one of the great and terrible things about Linux is that you can say, it isn't exactly the way that I want. It's open source, I will change it, I will change all of this stuff to be exactly the way I want it. And then you get your own little branch on the tree. But there are lots and lots and lots of them. So, okay, so why am I talking to you guys about this? I've been doing this for a long time now. I had to update this now. It's been 20 years, which I still feel like I haven't been doing this for 20 years, but I'm in my 40s now, and I've been doing it for a long time. But when I was in college, I had my very first Sun workstation, Sparky, I called him. It was this little, they call it these lunch boxes, and it's about so big. And it's very small and had a very small amount of RAM. And then I also had, this was my first laptop. I got it around the same time. No networking, no sounds, no USB. Uphill both ways in the snow, you know. But installing operating systems on these was extremely difficult and poorly documented. You know, the Sun machine, they expected that you had a service contract and someone would come do it for you. And this, no one really, it was kind of complicated and no one really understood how to do it. So, why I'm telling you that, I am not a computer scientist. So, like many of you, I was a physics undergrad, and I came into this sort of accidentally. A friend of mine who was an electrical engineer, when we got these laptops, they all came with Windows 95 on them, and we all said, this is terrible, this is a terrible operating system. And he said, let's install in something that's equally terrible but more fun. And so we partitioned our hard drives and we installed Linux on them. And I got started messing around with this stuff because it just seemed interesting. How do I make this computer do other stuff? So, things to note. I was never a computer science person. I really like to nerd jam, as I call it, like talk about this kind of stuff, but I am not an expert. And if you really want to try to, like, you can one-up me. You will know stuff that about Unix, Linux, other things that I don't know and that I'm not familiar with. So my purpose here is not to be all-knowing, right? You are all moderately equal to me in truth. Like, I've just been doing this for longer, okay? And so my knowledge in this area is a reflecting pool. It's very broad. I know lots of things, but I don't know them extremely well, okay? This covers things in radio astronomy all the way through the computer stuff, which is what I do. I have, over the last 9 years, have learned radio astronomy by being near it, but not by studying it. So I know some of it, right? And I know some of how it relates to the computers. And I know computer science by being near to it, but not by studying it, okay? So, and the reason that I approach things this way, or partly because it's because I didn't study them, but also I'm really interested in solving problems. Solving problems does not mean understanding how every tiny bit of the operating system works, how every tiny bit of the computer language works. I'm not interested in that, and that's not why I'm here. Okay. So, right, your goal in life is not to be a systems administrator, and you guys want to do stuff. Like, you're using the computer as a tool. This is something I realized, it's more personal reminiscence, right? Maybe, I've been doing this for 20 years, I'll say 12 years ago, I realized that I was really interested in computers as a tool. They're a thing that helps you get stuff done, instead of being interested in them for their own sake. There was a point in my life, and perhaps some of you are there now, where every time a new processor was released, every time a new GPU came out, every time a new something happened, I was like, yes, give me this information. I want to know every tiny bit of information about this computer. And at some point I realized that if it works, if it opens a web browser and a terminal, I'm happy, right? Okay, so, and if you, which many of you I think now already know, if you access a machine remotely over the internet at a university or an observatory, somewhere else, anywhere in the world, it will be running some form of Linux. And if you aren't comfortable working on a command line, you will have a really hard time getting things done. There's, of course, you can use VNC. You can do graphical desktop things over the internet, but they're kind of slow and a little pokey. And a lot of times the fastest way to get things done is to just be able to type it out. So if you can't just type it out, it takes you a lot longer to get things done, right? Okay, so who here has heard of GNU software? Okay, so some of you, it's sort of like this loose organization. They wrote a bunch of the fundamental software that's involved in Linux. And this guy right here, Richard Stallman, he's like a free software advocate. He's really strongly against like paying for software and other things like that. So he's really on one camp, and of course, like we all know, Neil deGrasse Tyson, famous kind of astronomer. Okay, so when you have a problem, how do you ask the right questions to solve it? And that's the other thing that like is important to learn. Who here has tried to solve a problem with their computer using Stack Exchange or something like that? Right. And so perhaps you've discovered that if you ask the wrong sort of question, it's very hard to get a good answer out from somebody, right? And that if you aren't asking the question in the right way, maybe the answer exists already, but you won't come across it because you're not asking the right sort of thing, right? So there are some fundamental things that you need to know. But yes, we can be difficult. So people like me can be difficult because we forget that we've been doing it for 20 years and we sort of absorbed all this information, right? So I try really hard not to be difficult. If I am, I apologize. All right, and there's a lot of bad advice on the internet in all areas of life, but especially in this. There's a lot of bad advice. So blindly following instructions that you get on the internet can sometimes lead to problems. All right, so the other thing that's important is, I was talking about earlier, the PDP-7. We went from these big computers where everyone had to use a terminal and access them to personal computers. There was a point where the personal computer was much better than a shared system. And so we were all using personal computers. And now we're back to using computing clusters and things where somebody else has hardware that's better than what's on your desk. And you're doing most of your processing not on your own laptop or on the PC that's sitting beside your desk, if you have a PC sitting beside your desk. Who actually has a desktop computer sitting beside their desk? Right. And so, there was a point in time where everyone had a desktop computer sitting beside their desk, and now most of us, if we can't do it on our laptop, we have access to some system where we can probably do it. Right. Okay. What else have I put in here? All right. So, again, most of you already have tried Linux, apparently. So, but the hardest. We'll start from hardest to easiest, right? Hardest way to try Linux, if you haven't before, is to just take a computer and take an installation and try to install it on the machine. In actual fact, this is now really easy. This is like not complicated. Usually you just plug in a USB and you say install and it mostly will work, which is kind of a miracle, to be honest. If you hadn't done this like 15 years ago, 20 years ago, like as an old person, it used to be really difficult and you had to spend a lot of time making specific adjustments for your hardware. Not anymore. So it's actually pretty easy. So moderately hard. Install some virtualization software like VirtualBox and download a machine image and use it that way. Also moderately hard, what I've asked you all to do already, which is install Docker and pull a Docker image and try to get it working on your laptop. So that falls into the moderately hard category. Less hard is to make a bootable USB drive and just boot to that and try it. So those are different ways to do it. All right. And then say you aren't using your laptop, but you've connected to a remote machine, and you're having a problem. One of the first things that's helpful to know about the system, or helpful to know, is what sort of Linux you're using. And there's two major families of Linux, and they are Ubuntu. Now, or I shouldn't say Ubuntu, it's a Debian family. But most of you, okay, who has used Ubuntu Linux before? Or some variant. We'll call it like Mint or There's a whole bunch of names. They all fall into that tree. Okay, who has used something from the Red Hat family? That's Red Hat or CentOS or something like that. Okay, so most server machines that you log, I shouldn't say most, many server machines that you encounter will be some Red Hat variant. They'll either be a proper Red Hat or this thing called CentOS or possibly Scientific Linux or there's one other one that's similar. Maybe SUSE, but I don't think that one gets used very much anymore. So there's a command that you can run that's called lsb release, Linux Standard Space Release, that will tell you what you're on. So that's a good thing to know, sort of how to find out what version you're on. Now, this you can see is old, if you know what this means. This is also old. This is from 2016. But we'll look at that in a second. All right. So once you know what distribution you have, you sort of get a general idea of what default software is installed. And one thing to note, that on servers especially, software moves very slowly. So if you're remotely accessing a server and you're trying to run Firefox on it, if any of you have ever tried to run Firefox on a CentOS 6 machine and tried to access something on the modern internet, it kind of doesn't work very well. And it's hard to update things like that. Things that are desktop applications on servers tend to move very slowly. Cautious, conservative. If it works, you don't want to change it, right? If it's your personal machine, it's probably running something Debian-based Ubuntu or something like that, and most likely it's a lot more up to date. Sometimes, depending on who you are and how cautious you are, I'm going to call out Tim, who I don't even think, what version of Ubuntu are you running on your laptop? Is it a 14 something?
1404.
Yeah, he's still running 1404 on his laptop because he's concerned that if he updates it, it's like, once you get everything working, you're like, I don't know if I want to mess with this. And so some people are very cautious. I just kind of say, oh sure, let's update to the newest thing and see if it works. It's fine. All right. Okay, so to give you an idea of how slow Red Hat is. So version 7 was released in July of 2014. I'm a systems administrator. I have a few clusters. I haven't yet updated the head node of my cluster to this, and that was 5 years ago that it came out. I'm still on this. I'm just now installing machines with this. So you're conservative in this area. It's very, very slow, right? So this is the support matrix for Ubuntu. And so if you're using Ubuntu and you've heard somebody say an LTS release, that means long-term service. And you can see here on the diagram that once you start it, they make new updates and then they maintain like security updates for a pretty long period of time, right? So 1804, the one that started in April 2018, updated through 2023. And these ones are shorter. They aren't long-term service releases. So these, they stop supporting as pretty much, as soon as they're pretty confident that the bugs are worked out of the next release, they stop supporting them. And you have to move on. Okay. All right, so that's all just kind of general Linux stuff. So we send out an email and ask people to get Docker installed on their laptops. Who was successful installing Docker? Nice. You guys are good. This is great. Okay, so who was not successful?
I mean, I couldn't believe it.
Yeah. Okay, so like so we have only a couple of people. That's impressive. Man, you guys are making my job really easy. I like this. Okay, so why do we use Docker? It's a container system, and it lets you install the operating system in a way that accesses all of the hardware and the current operating system, but doesn't really touch it or interfere with it. It's reproducible. It's kind of easy to share images on the internet. There's a public repository where you can push them. You all did a Docker pull and grabbed the IPTA image, and it came from something hosted on the cloud, not by me, or I didn't have to worry about any of that. it's out there, and you guys were able to pull it, right? So it's public and it's easy to share things that way. So it's really good for that. It can be used on most modern hardware. So if you have a newish laptop or a desktop or something else, it will work. We have been trying to use it in our collaboration for reproducibility, because you can say, I'm going to build this Docker image, and it has this version of this software, this version of that software, whatever. And then you can leave it, and 2 years later you could come back and you could process your data with that image again, and it would work. So it's a way to say, to be able to work on scientific result reproducibility. When you release your results, you can also say, here is a Docker image that is tagged right here, and it will work. And you say, you want to reproduce my results, pull this Docker image, run the software this way, it will work. And you can be relatively confident that will continue to function for some period of time, maybe 5 years, you'd say, afterwards. So it's good for that. The things that are bad about Docker, maybe requires a little, you guys, so who knows what root means on their machine? Okay, all right, so if you have root access to your machine, that means you can do anything. That means you can delete all the files. That means you can delete other users. That means you can do anything, right? Docker on a machine runs as root. So even if a person doesn't have root access to your machine, if they can run Docker, they have root access to your machine. So people in my position, systems administrators, people who manage computing clusters, they don't like to use Docker very much because of that reason. You don't want to give, go ahead, yeah.
Does it, is it root not only for that image, for that container, or even for your actual?
It's root, so it's root just for that container, but you could do something like your root on the container, but you could mount the whole file system into the container, and then you would have access to the whole file system as root.
But if you were to then change something on that, it wouldn't be changed on the main file system. Is it more just like a security?
It's part of it's a security thing. It's mostly that you can't, so there's the difference between, I'm not going to draw it. Okay, there's the difference between the file system that the container is using, right? And which, yeah, so the file system uses, the container uses this file system, and that doesn't touch the operating system. But you can add part of the operating system's file system into the container, and then you can make changes to that. It's part of what I asked all of you to do, I think, in the instructions, was to make a shared folder that you would mount into the container. But you could, being able to run the container, you can arbitrarily mount anything into that, and so you can make changes to other stuff. So there are different kinds of container systems that people who are systems administrators use. One, has anyone heard of Singularity? Okay, so a few, I figured you guys would have. There's one called Singularity, which does a similar thing, but in a way that's a little bit more secure. So you might run across that at some point. And it works in a very similar way. Okay.